Hi, welcome to video 4. In this video, we will learn understanding a banking example, creating a banking example, understanding inheritance with a real case using this super keywords in Java, overriding methods, polymorphism, and introduction to dynamic method dispatch.
So now, the moment I say banking, we have to classify the entire story into three segments. So any business, anything which you're gonna do it from here afterwards. Now, first and foremost, let us try understanding what will be classes, what will be variables, what are the methods. So these are the whole stuff which you have to have it. In order to build classes, do ensure there should be something called as parent-child relationship. Only then our purpose is solved. Okay, let me just put anything. Savings account, current account, paying bills, withdraw. Mortgage, deposit. So there's something called check balance, credit card, type of credit. There's a quick pay, home loans. I'll just put it home and business because they all come under loans. Education, transferring funds. Now, when I say class, a class is a noun. So we just have to go back to our college days or school days when we tried having some introduction to English. A noun is something in the world which is, um, how do we say this? The noun is the living being. Um, it is thing, object, which is tangible or intangible. Now, what does this mean? Imagine if you just have a look at the banking concept or anything in the world, anything which you can touch and feel or you don't touch and feel are called as nouns. Now, something like this. A account is a noun. You can feel that. You can feel there is an account. But you cannot say balance is my noun. Balance cannot be a noun. Now, I just want to contrast a very simply. When you say account is like a human. A balance is part of the account. So it's like your hand. I cannot say hand by itself is a noun. I had to be very clear here. Now, if I go to college is a noun. I cannot touch and use it, but I can feel that. I have a transaction. Transaction is a noun. Transaction will have a money or some amount. Either it is credit or debit. They're all the properties of the noun. So let's understand that very clearly. There are various nouns in the world. For example, I'll say account is a noun or it's a class. I have human is a class. I have a recurring or current account is a class. Savings account is a class, right? I cannot have uh, transfer as a class. No, This does not. Because if I try having some noun or some class, we should have the variables and methods for each of them. Let's be very clear. We have to have variables and we have to have methods for it very clearly. So if we just consider this and go back and try drawing a diagram here, just to start with the class first, I will have a class which is called as account. So you'll have somebody called account. Account is my class. Now this account as in a class will have some children. Now, why did I do this account at the topmost and why am I creating children? Okay. Now the whole idea here, if you want to make something reusable, understand this very cautiously. If I try having an account here of type savings bank, and I'll have an account which is called as checking account or current account here. Can I say SB account is a account? Current account is a account. Make sense? So you have to when you have this context of talking to somebody, hey, I have an SB account with BOFA. Perfectly fine. It means SB account is a account. Now, if you say me, hey Naveen, I have an account with BOFA, now I will be particularly asking you, hey, which account is that? When you tell me something called as I have an account, I'm a little vague. It meaning I try saying, oh, you have an account. Now I have to understand, is that a savings bank, recurring deposit, or a checking account, or blah blah blah, whatever it is. The whole idea here, when we try having inheritance, is to create an architecture in such a way that all your generic information will be stuffed here. All your specific will go here. Now we have to identify so intelligently that there are some fields, some methods, some variables in the account class. There are some variables, fields in the savings bank. So which will differ. So that there are some common properties here which are inherited from account. So that account gives it. Does the SB account and CA account have balance? So anyway, tomorrow you have something called as recurring deposit account. You open it for your kid or for yourself. Does it have balance? So now what I can do is instead of declaring three variables here, can I declare it here? When I declare, I can always make use of these attributes in the child section. So now the whole idea here for us to identify something like this. Oh, we will have a noun or a class. The class will have an attribute. If I have it as a generic class, then that should be utilized in all the three classes. By doing this, we'll save a lot of time, memory, space, and all in the system. So tomorrow, if I have, imagine bank announces we have 500 different types of accounts, perfectly fine. What we can do is we can only have balance declared in account and balance is given to SB account, recurring deposit account, checking account, or anything for that matter. So now let us go ahead. Let's go a little deep and try understanding. Hey, Naveen, we have this account. We have SP account or checking account. So now we have to get in detail of making this as to identify what methods, what variables will have it. So one important thing when we say something called as banking, loan does not come because loan we have to treat it as a different entity because the kind of application which we are building is more of highly cohesive. When we talk on the loans, loans are like mortgage loan, business loan, education loan, home loan, etc. kind of thing. There we try having EMI, the sanctioning amount, the person who sanctioned, all these things. All right. So in such case, loans can be used. I just don't want to mix and match this. So now, in my uh, account, I will have few things which is separated from each of it. For example, every bank will have rate of interest. So I'll have ROI. So rate of interest meaning when you keep money in any of the account, every bank in the world have to give the interest for the money kept. Is there any bank who says no, 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 we will not give it? No, there's nothing like that. So what I did, it is just trying to map in my brain, saying that there are some things in the world which everybody does it. So if everybody does here, I will keep it here. If only SB account does, I'll keep it in SB account. If only RD account does, well, I'll keep it in RD account. If I have something which is done by CA account, then I'll keep it only in the CA account. I have an account. Account is a class because when you say account, account is a vague, but it can have a lot of data. It's something like rate of interest, I can have balance, account number. So every account in the world will have account number. Every account will have account number. Or let's call something like instead of owner, Let us call customer. We'll have something called as customer name. Customer name. So now let's go to little specific. Only those attributes which are there for savings bank, which are not their minimum balance. So I'm sure that the SP account is one account which can give pension, and CA account, when you try having it, they give you OD, which is overdraft. Many people call it overdraft, or it is called as business loan. Let us go back to our Eclipse. I will close all those files, and we may just have to create a new package where I don't want to make too clumsy. I'll create a package. I'll say com dot, I'm sorry, it's all in lowercase, com dot sdet dot day4. Day4. All right. So here, let's create a class. So the class is called as account. So the first class is called as account. So we have nicely identified few attributes. Let us try doing alt tab a couple of times. I have account ID, the rate of interest, the balance, customer name. All right. So I assume account ID is always the integer account number. So this guy will have rate of interest, private double, ROI. This is perfectly fine. Then you have balance. Every account will have a balance and a customer name. Customer name. Then I'll have balance. Private double balance. Now let us go ahead. Try identifying some important thing. We need some methods. We need some methods. When you have method, you will have public void uh, debit. I'll have public void credit. So there are like two methods which are there. I don't want to make too much complicated here. We just keep it as simple as it. So when you say debit amount, I will take a parameter which is double amount. I will just check if the balance is greater than amount. Then I'll say um, something like a message. We'll say the transaction debit amount amount is successful. Else, uh, sorry, no balance. Make sense? Amount not of. Hope this should make sense. And then credit is pretty simple because people will not ask you any questions to credit the amount in the bank. So what I do is I'll try taking this guy who's called amount. I'll say uh, this dot balance is equal to this dot balance plus amount. Hope this is good. Okay. In addition to all these things, we may have to have some opportunity here to set the values. We want to set the account number. In order to set this value, I can go ahead and try using setters. That's absolutely fine. That's it's your choice. Or I can try using a parameter constructor. So anything is good for you. So since they're all there, I just quickly want to have a parameter constructor. In order to have parameter constructor, I'll go to source, uh, constructor using fields. There's a quick thing which is possible. You don't have to type it. You just have to click. This guy will give you a constructor for all the fields. I'm good. Say okay. So somebody comes and says that, hey, I want to know what is the rate of interest for account, right? So I can have a getter. I can have a getter. So for rate of interest, I can go to source, uh, generate getters and setters. I just have to expand it and check where is rate of interest. Rate of interest is here. I want to get the rate of interest. Perfectly fine. Look at this. This is a nice thing. When you are trying to use Eclipse, things become so fast. You just have to do a click, click, click. So here, if somebody asks me, hey, I need a method to know what is my customer's rate of interest. I want a method for getting the balance. I want a method to get the customer name. I want a method for getting the account number. You can go with your own method, absolutely fine. No, I can write the method, whatever name I needed. Since we just want to follow certain guidelines, some rules, it is good to go with getters. So if you want more, what you can do is go back to source, generate getters and setters. Here you also have select all the getters. So we can even get only the getters. Let's say, okay. So here, all the getters. When you want to set it, we don't give an opportunity for people to have setter. We want to give it everything with balance. And if somebody is, because I assume that the rate of interest, the customer name, account number is not something which we're gonna change every day, but balance is changed in everyday basis. For that, we have a strong business logic written here. So what we have done so far is we tried constructing something in this, so which you have constructed. Let's go back and try introducing what is called as SB account. SB account. So now I'll keep this. Of course, this class can grow to a really, really large extent, but somewhere we have to stop. I'm stopping it here. So now I want to have another class, which is called savings account, right? Savings account. Now, savings account extends account. It means all the properties of the savings account has come to this. So imagine this is your parent, this is you. It means all the properties your parent has is got in this as well. But there is a little problem now. It's not a problem. It is something which we have to understand very importantly. Whenever I try having a class which has a parametric constructor, and the subclass should also have a parametric constructor of the same signature which it accepts. If not, this will be an error. To prove this point or to understand this, cautiously try knowing it. This is something not as a human being like me and you will do it. This is something which the compiler will do it, because compiler plays a very important role when we try fixing in the code here. Let's understand this. Imagine if I have a class which is called as account, right? And if I have a class called as savings account, okay. Now this savings account will have a constructor. Let's consider something like this. I will just go ahead and say savings account S is equal to new savings account. So this is perfectly fine. In fact, behind the screen, what would happen is this guy, this guy will eventually extends. This is what we're supposed to do it. Then, if you don't have a default constructor, there will be a default constructor given by the compiler. So that's the whole idea. I can copy this and put it here, and this will be a constructor. So here something will go. What this guy does is there will be a constructor even here. Since you don't have the default constructor, the compiler will give you a default constructor from our yesterday's discussion. Account, I'll have account. Here you'll have it. In addition, do we also remember if your class has extents or if it does not have extents? And please have it in our understanding. There is no class in the world which does not have extents. Every class in the world has extents. If you don't have it, the compiler will implicitly put that. So now if you have it, something like this, in order to invoke the superclass, there will be a super keyword. It means before creating the object of this class, it will go to superclass, which is here. And what does this guy has? This guy will also have super. This will eventually point to object class. Now, what we have done, understand, there is an account class. We don't have a default constructor. Since we don't have default, we would have put something like account number something like double balance. I'll just put two parameters, uh, double balance. Okay. So now, if you are trying to create an object of savings account, when you see a default constructor, the things are perfectly fine, no problem. It goes here. But unfortunately, it tries invoking what is called a super of no parameter. But in the account class, I don't have a constructor which tries taking no parameter or no argument constructor. So it gives you an error. It says that, okay, boss, we tried having super, but unfortunately, I cannot find a constructor which takes a parameter. Now, what is mandatory here? You have we have to invoke saying that, okay, I will pass a value called as 10 101 or some balance. So this meaning you have to look for a super class which takes 10 and 23, which is 10 is the first parameter which will go and set for account. The second parameter is 2323, which will go and set for balance. In order to do this, generally we accept the parameters here, something like int account number double balance. So what I can do is intelligently, instead of passing hard-coded values, we can say account number and balance. So when we ask end user to create an object, we'll say, hey, look at this boss. We always accept the parameters. So what are these parameters? I'll say 10, I'll say 2. This is what it has to be done. So we have account, we have savings account. So it is mandatory that we have to pass some value. So something like this, right? So what we do is we'll go back, just hover, just hover on the class. It says add a constructor. Look at this. The moment I add a constructor, it takes all the stories which I needed for superclass. It is auto-generated. Of course, you can go ahead and type it, or you can ask the Eclipse to do a bit of job for you. So what this guy has done, he's got savings bank constructor, which takes all the parameter. It will all send it to super. It means it is setting for super. Now, how do I represent it pictorially? Imagine yourself, if you are trying to create an account of savings bank, this will have invariably somewhere in the cloud. Now, savings bank, I just want to do a little where we don't want to stop it. There's another guy who's called as pension. So I just want another variable. I just want another variable which is called uh, private double pension. So probably government has a class if you have an account which is maintained for like 20 years with some balance, blah blah blah, some government rules, then the bank will also give you the pension. No, they'll just link that. So what I can do is, since there is a pension, I have to somehow set this value to pension. I will also accept pension. So this way, what happens? This dot pension is equal to pension. So what happened? Understand this very clearly. You got five attributes. Out of that, four I have sent it for parent. One I am setting it myself. If you could understand this little cautiously, if you have a big tree of multiple levels, every class will have the responsibility of setting the value something for themselves. For example, here, just have a look at this. If you have one level, two level, or something like this, I have one level, two level, three level, fourth level. So every level here, when you're setting the value, I can set some value partially here. I can give it to this guy. This guy can set partially. Give it to parent. This guy will set some partially. Give it to this guy. This guy will set it something partially. So this way, what happens? Everybody will have a responsibility. The good idea is if you start having setting of values here at this level, at this first level, tomorrow if I have a child, even here, if you pass four parameters or 10 parameters, if you pass 10 parameters, you don't have to take care of all 10 parameters at this level. You can pass partially here. Probably you can keep two, eight is given to this guy. You can keep two here, give eight to this guy. So that way, everybody have a job. So that you are making your application highly coupled. Highly cohesive, loosely coupled. Let us go back. So here, we have pension. So if somebody want to know what pension I'll be getting it, so the good idea is go to source and generate getters and setters. So here in the pension, you should see get pension. Okay, okay. So this is fair. This is fair enough. Okay. And did you also notice very importantly, the savings bank account will have debiting and crediting. We're not doing it here. We're not doing it here. It is all done by account class because this guy is common. Now have an interesting thing which going to happen for reusability. I'm going to create another class which is called as a current account or checking account. So what this guy does, this guy whose current account will extend account. It means this is a account. So I'll take perfectly fine. This is awesome. So here I'll hit enter. I will just have another variable, private, uh, double overdraft. So you will be asked, oh, you are having a checking account. We can also have the overdraft. All right. So now I have few parameters which I want to send it to the super class. I'll say this dot overdraft is equal to overdraft. Assuming that I can copy this and put it here. Put it here. Double overdraft. Now, if you want to see what is the overdraft, uh, I'll say public. Maybe I can quickly generate the getter for it. So what I can do is go to source, generate, getter, perfectly fine. Perfectly fine. So now let's quickly understand what we have done. So we have this class called account. We have account, we have savings bank, we have checking bank. So I want to do a quick copy paste of the code. Here it is. The first and foremost guy who's going to come in our story is account. So we're going to go ahead and paste it. So this is good. So here I'll have with all the parameters. So this seems good. So I have all the values here. And this guy who is called as savings bank has got only one variable. And this is called as pension. This is perfectly fine. Then he will have account. The account is so this is account savings bank. This CA account. Is that good? So every time when some job, if there is an end user who's gonna come, he will sit somewhere here, invoke it. But it has to invoke the superclass, invariable. Behind this, there is another story where you have object. Okay, so that's something which is important. So you cannot take only pension, but you have to take pension plus this parameter because you are invariably a child of account. So you have to understand in this pension you have this plus the account class. So what is there in the account class? You will have this. The similar fashion, this overdraft plus there are variables of this. I want to create a class which is called client. Okay, banking client, banking client. So now when I try creating a banking client, I will just say, hey, look at this, Mr. Savings account SA is equal to new savings account. Now, when I do this control space, it gives me a list of options which you have to manually enter. Something like account number, I'll say 101, the rate of interest, I'll say 3.5, the customer name, let's say Lakshmi. The balance, I will say like initially to start with, I'll have $1,000, and the pension, I'll have every month something like uh, $350. So if you're maintaining an account forever, then you will have this amount. Who will hold this? This is all taken care by savings account. So now a quick thing here to understand, quick thing here to understand. Uh, If I just put something like system.out.println, all right, sorry, I've got main method. I'm sorry, because this is an executable statement. So here I'll say system.out.println, yes, a dot, look at this, when you do getter, all the getters are got. So first and foremost, we have to understand the account number is got. The account number is not in the savings bank account. Look at this. This get account number is not in savings bank. It is there somewhere in account. So here I have get account number. So looking at this diagram, be very cautious. If you have methods, then the methods, then it is also given for child. So what methods you have? Everything is going to this SCA and SB account. Now, very importantly, we try creating an object of pension. Good. Let's go back to our code here. So I can say, let's go back here, here. I want to get SA dot get account number. So I just put this guy here, account number. Fine. So I'll say system dot out dot println and what other details we have. We want to get the balance. We want to get the balance. SA dot get balance. I also want to have something like current account. So since we have done some good job, let's quickly do this. Current account CA is equal to new current account. I want to have another customer. The account number, I just keep a different series called as 201. Rate of interest, I'll say 3 point or maybe like 4.8. The customer name, let's keep it like Ashwini. So I'll have the balance of like 4,000. And they also have this opportunity of, since they have the current account, they have the opportunity of having the overdraft account amount of like $25,000. So they can take that loan. So now I can just do system.out.println CA. So what is the CA referring to? CA is an object uh, which is referring to uh, variables to be printed in account class. Account class. So now let's go back and do this system.out.println overdraft amount is CA dot get overdraft. Perfectly fine. So let's give a nice separator. I just give a separator just to differentiate. I'll click on play. Oh, great. Look at that. It looks so clean. It looks so clean. So I have the savings bank account. I also have the checking bank account. And there are a lot of properties which the parent is being taken. Now the actual story starts. Imagine, imagine if you are from savings bank account and you want to debit the amount. Here I would say, hey, savings bank, I want to debit amount. Okay, good. You can go ahead and debit amount. So what is the amount to be debited? I will say um, I want to debit something like $200. Or if I have $200 today, I want to take it. Then I'll say system.out.println SA. Right? I'm just printing it again. So let's go ahead and check this system savings bank account. Have a look at this. Have a look at this output, which is highlighted on the first segment. So my balance as of now is $1,000. I get this pension and transaction debit of amount 200 was successful. The remaining balance is $800. So now if I say something like 2000, I don't have so much balance. Then I click on play. Then I click on play. Here, oh, it says sorry, no balance amount debited because you don't have $2,000. The existing balance is 1,000. I hope this is making sense for us. Eventually, we are all hard coding it. Over a course of time, this will be pulled from database or Excel file or whatever. So let's consider this as a miniature of things which you are forecasting in the future. So I will just say, hey, this is good. We want to have $200, but there is a condition. There is a condition that you can always do this debiting and uh, crediting perfectly fine. But if um, the amount is greater than 750, the bank says we don't allow. So any savings bank account, if you want to do debit or credit, or crediting, you can do up to some level. But if you want to debit an amount, we don't encourage you to do over 750. If not, you are penalized. Something like this. So in that case, do understand there is no opportunity for us to write the business logic here because this business logic of debiting and crediting in the account class is all taken by tomorrow I can have checking account, current account, or recurring deposit account, somebody like a savings account, whatnot. Everybody refers to this guy because he's a parent. But where do I got to write it? I have to write it somewhere here. Somewhere here. Where is this? This is in the savings bank account. On the verge of understanding this for savings bank account, I want to introduce one more feature, which is inheriting or overriding the methods of superclass. So if you look at this output very cautiously and just see this output, sorry, no balance amount, it is not depleted of 2000, perfectly fine. Where is this coming from? This is all coming from the class called as account. But unfortunately, we don't want to delegate the business logic for the class called as account. Rather, we want to have a stop of this method because if you do this debit amount of something like just assume that you have a balance of like $7,000 and you come today and say, oh, I want to debit $5,000. Good. But your account will just go ahead when I click on play here out of 7,000, 5,000 is deducted, 2,000 is left out. But our bank rule says that, oh, no, 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 you cannot have anything over $750 per day as a transaction amount if it is savings bank. How do we do it? But unfortunately, not here. We want to do it elsewhere. Where is the right place? It is in savings account. In savings account, what I can do is I can try having public void savings debit amount. This is perfectly fine. You can try having the method name of what you want, but preferably let's not. There is a good mechanism of doing it. So let's try understanding it. In this class, I'll go to source. I will have an opportunity here to override or implement method. Here, if you have a look at this, there are a whole lot of methods which superclass can always give it to you because they are public. So wherever you see this, when you're working with the Eclipse, very cautious note, understand few colors. Anytime you see green, they are called public. The green color is always public. There's a blue color which is a default. There's an orange color which is a protected. There's a red color which is private, right? So private variables are only accessible inside. You know? So here I want to debit. So I want to override this method debit. So now what happens? What is happening here? When you invoke, keep this aside. Look at this. When you invoke debit amount in the previous example, since your SA, who is savings bank account, did not had debit amount. It went to superclass because it is extending superclass. Then the debit amount was called. But this time, what we do is we are planning to override it. We are planning to override. Since we are overriding, what we can do is we can write the rule here. We can probably write the rule here. So the rule here is, anyways, the business logic of debiting and crediting, we're not going to change in account. We keep it as it is. Now I'll check if the amount is greater than $750. Then I'll say system dot out dot println, sorry, transaction transaction cannot be over 750, right? Perfectly fine. Else Just go ahead and debit it. Look at this. The whole business logic of whatever complication savings bank account is not handling. Who's handling it? Account is handling. So tomorrow, if I want to have the same business logic or want to check of some amount, I just have to put the class. All this story of debiting, crediting is all taken care by generic class. That is where the power of Java will start shining. Let's go back to our client. So who is our client? He is banking client. Let's do little job. So today we decided to have a debit amount of 5,000. Let's see what happens. Oh, sorry, transaction cannot be over $750. They made it very clear. Though you have balance, because what you are looking for is like 5,000 here, but you are not allowed to access the amount. That's something which can happen in our case. Look at this. The amount which you wanted is 5,000. It is there. You have the balance of 7,000, but still I get this error because this is all happening in savings account business logic. Yes, let's have a look at this a little clearly. This is more important. This is more important. When you try creating savings bank account, there are some variables which are stored in the heap. There are some variables which are stored in the heap. The savings bank account, which it tries having it, as of now, it will try having a variable which is called as pension because that's part of savings plan plus plus here. So there is another object which gets holded from this. So from this heap memory, I'll have another object. Now, what is this variable holded? This will have account number, balance, uh, rate of interest. What was the last variable? Account number. Yeah, customer name. So we wanted customer name. So customer name. So this is right. Now, on the verge of it, this is something which happens in the heap. There's another place where something would happen. This is your method section. This is your method section. What happens in method section? Have a look at this. In your method section, all the methods from account is kept. I don't want to keep all the methods because it is just consuming too much space. I want to have debit amount. Debit amount is coming from account class. From account class, I can have something called as debit amount. In similar fashion, from account class, I will also have another method which is called as credit amount. So this is perfectly fine. And similar fashion, we have all your getters and setters. Look at this, you have some nice getters and setters here. They are all coming from, though we are trying to create an object of savings bank, it is all referring to account. There is another thing which gonna happen, very important here, which is with the savings bank account. Have a look at this. In savings bank account, there is a method. There's a method. What is that method called as? Get pension. Get pension. This is the only method which will be loaded from savings account. Okay. So this will be loaded from savings account. Now what happens when you try doing when you try doing when you try doing SB, which is savings bank, dot something like credit amount. Understand this very carefully. If I say savings bank dot credit, in reality you don't have anything called as savings account dot credit amount. Here it is not pointing to savings account. It is pointing to which class? Account class. Now this is little interesting. What happens? It will try taking an instance of this class, which is called as ESP. Now, I'll just try writing a quick story. ESP is the child of account. Do you agree with that? It means SB, who's a savings bank account, is also account. Is also account. SB is an instance, just an object, which is also an account. So since it is also an account, it has an opportunity for referring it. SB is a variable of savings bank. Since it is a variable of savings bank, it is a child of account. So it means SB is also a child. For example, if I am a child of my dad, I'm also my dad. Of what? Whatever properties he gives, I will take. Plus, I will have my own properties. If he is giving some properties for me, maybe a lot of times we are acknowledged, hey, you look like your dad, you walk like your dad, your eyes are like your dad. So, whatever. So, it means an acknowledgement which I have not bought something by myself, I have got from my parent class. So, now let's quickly understand one more thing. Here in our business logic, whenever when I do the client, all these methods are referring to their own classes. When I say debit amount will refer to account class. They don't refer to savings account, but they get inherited. Now, very importantly, so we're going to start something new here. Imagine, imagine if you have a class, for some reason, this is called as account class, and there are savings account, there is checking account, there is RD account. There are a whole lot of classes. There are a whole lot of classes. Imagine like hundreds of types of classes are there, where all these classes go and inherited from this parent. There are hundreds of classes. What I can do is I can go ahead for this whole stack of classes. I can say, okay, savings account. I can do something like this. I can do something like this. Savings account. S is equal to new savings account, right? I'll say current account C is equal to new current account. I'll say recurring account, recurring deposit R is equal to new recurring deposit. Now, and so on. You have 1,001 classes, 1,001 different types of data. Now, my simple question is, hey, anyways, we have put so much effort of building this class called as account. A. Can I say, can I say something like this? A is equal to this, A is equal to this, A is equal to this. So my question for all of us is this. Can I try writing something like this? I just want to give a quick example for us to understand. I'm sure that I come from India. We have some rules in India to behave in the home. We just not like behave just like this. And of course, most of us would have undergone this you know, experience. I have a class called as a parent, who's my father. So what my father does is he is having a method which is called as educated. Now, what is my father's education? I'll say he is a grad in commerce. Commerce. Okay, so he is his bachelor of commerce, and he is got another method which is called as spiritual, spiritual. Right? So he does every day. He goes to temple, performs his daily rites, and so on. So he is spiritual. So he goes to temple. So that's what he does. It. Now let's assume my father has this many methods. I also has something called as public void walking style. So he walks. He walks. Uh, he walks. He walks in some style. how he walks. He walks in some style, right? So then imagine this is me, or this is somebody like you. So this is like you, who extends the father. The moment I extend the father, when I say u y is equal to new u, it means all the methods are loaded for you as well. All the methods are loaded for you as well. So now have a look at this. Very importantly, when somebody says y dot walking style, this meaning, this meaning, it is not you're walking, you're just following the dad's walking style. When you say y dot educate, this is you. When you say educate, your Java will look if there is a method which is called educate. If it is there, it will invoke. If not, it will invoke something here. That is what was happening so far. If you look at my class, here in banking client, if I say debit amount, if debit amount here in savings bank, if it wasn't there, if this was not there, if it was not there, then it would call the super class. Fair enough? Fair enough. Now, I can always have these properties overridden. When I say overridden, I can take this method and I can override. I can override. And he says that education, I am a graduate in computer science. This meaning, when you invoke educate here, the output of this will not be graduate in commerce, rather graduate in computer science. Likewise, you imagine you have a lot of siblings. You have like there are a lot of children, which every parent will have it. Imagining some scenario like this, everybody will have their own behavior plus the behavior of father. Every time, if you want to set by yourself, you don't have to really do it. I just want to create a simple story of that. This is you. This is a class called as sibling extends father, father. This is sibling. This is sibling one. This is sibling two. Imagine if there are like hundreds of siblings which are gonna be there for every class. Then, how many objects you have to maintain? You have to maintain an object of you. There is something called as a sibling. S is equal to new sibling. Sibling S1. So like this. One, two, one, two. Everybody is different class. Every time you want to do a business logic, you invariably have to call their own methods. Rather, what I feel to do is I just want to keep everything in you. This is possible. In Java, try knowing it, try knowing it. I can have an object of somebody like father F. Then I can say I have all the properties of it. This meaning now F is a new sibling, which is child, obviously. If you see here, the father is a parent of sibling 2 or sibling, whatever. This meaning all the properties which father have will be loaded. Now, the properties of child will be loaded only and only if they override the behavior of father. Only and only if they override the behavior of father. If not, that are not taken. Just to prove that point, what we do is let's go back to our class. Let's go back to our class. Here in banking client, here in banking client, so here account, savings account, yeah, banking client. In my example, we tried having savings bank account and tried executing it. Rather, what I want to do is I want to have, okay, I don't want to disturb this class. I don't want to disturb this class. I'm going to create another class here. Most of it, I'll rewrite it. Banking client one. Here, let's have the main method. I would say account, which is a super class, account, account, right? Now I'll say account is equal to new savings account. Look at this. It means here we have to read it very cautiously. Account is called as a reference. The instance of account is savings bank. We have to call this very, very clearly. This is only a reference. This is the instance of it. So what I do is I'm gonna go back and create an account number, which is called as port one. I will have the name as Krishna. I'll have, I'm sorry, this is rate of interest, which is 3.5. I'll have Krishna. I'll have some balance. Let's consider like 8,000. I'll have like 800 as pension. So this is what which will have it. Now, since it is from account, I can just do system.out.println account. Perfectly fine. Perfectly fine. I can go back, click on play. Oh, look at this. Whatever is there in the account has come. But if I want to get pension, which is of $800, so here I say account dot get. Do you see anything called as pension here? You will not see anything called as pension because according to our diagram here, according to our diagram here, remember the account will hold debit amount, credit amount, rate of interest, everything is there. But get pension is something which I want to get from savings account. This savings account check, I have to have an instance of savings account in order to invoke get pension because it is there in the child. The parent does not know. The parent does not know. Just to give little contradictory, little funny example, probably in our childhood or probably when we did college, we had a method called party. So understand, we did late night party. So we have to understand this method called as party is not there in your parent. If the method is overridden, called educated, then this will be in. But holding a reference of your father, you cannot do party. Then who should be you? You should be yourself. You will get all the properties of your father, but your father will not get the property of yours. There's nothing like somebody has seen your father and said, "Hey, you look like your kid." No, nobody can do that. That's wrong. So keeping this in mind, it is possible for you to have your own methods plus the methods which are specifically required. There are few methods we do. He is spiritual. You don't have to be spiritual. He's got a different walking style. You don't have to have this. He is educated in commerce. Oh, you are educated, but this time your education is different. And you have late night parties. In similar fashion, have a look at this. Account has their own method. It has its own method. That's good. We can show here. It has its own method. But savings account has pension. It is savings account. Unfortunately, today we don't get an opportunity to see the pension here. In order to get the pension, what I have to tell my parent, I have to tell the parent reference saying that the kind of parent which I'm trying to take is savings account. Then for the savings account, I will have get pension. This I can go ahead and put in the printable statement. Yes. The good thing, what has happened here is you can hold the reference of account and pretty much do the operations of savings. I can hold the reference of account. I can create an object of current account. I can say 201, 5.5. I'll have Ravi. I'll have like some balance like $12,000. I'll have a overdraft of $45,000. Now, if Ravi wants an overdraft account amount, so I can always do CA. I'm sorry, this is account. So now look at this. The account so far was referring to savings account. So now account is referring to current account. This object, which is called as account, has become polymorphic. It has become polymorphic. Now I will just say, hey, account, can you help me to get the overdraft? No, I don't have overdraft here. Look at this. You don't have this opportunity of seeing overdraft. Rather what I do is I will have current account. In the current account, for that reference, get overdraft. Overdraft. Now I'll just do uh, overdraft granted is perfectly fine. And here I'll just give a nice separator so that we can see the output cleanly. Like this. That's where the stories are happening. And even here, when you say account, very interestingly, have a look at this. Account dot debit amount of like 7,000 because Krishna has uh, 8,000. Now she wants to have debiting of amount of 7,000. It does not invoke the account. Very cautiously, you have to understand it does not invoke account. It will invoke the method which is overwritten in savings bank account because account now is pointing to savings bank account. I'll go ahead and click on play. Look at this, your transaction is cannot be done because this is not happening from account. The account blindly does all the transactions, but here it is happening from savings bank account. This, if you are trying to do it eventually over a course of time, there is no fun. There's no fun in that. Rather, we have to build an application much better so that the code gets reduced. This is anytime you see this class which has a main method, this kind of classes are called as clients or whom we give it to the customer. It is always good to keep the customer code clean, less, it's more advantageous. All the complexities in our world we have to handle. For example, if I'm driving a car, when I drive a car, I just have to change the gears. When I change the gears from one to two, there are a lot of things which gonna happen. But the car manufacturer will not put that overhead on somebody like me and you when we drive the car. Rather, they handle it everything by themselves. That is where I want to do it now. That's what I want to do it now. So what I do is here, here, I try introducing one more guy who is called as accounts business logic. So accounts business logic. Accounts business logic. Have a look at this very cautiously. I'll have public void. This guy, this guy is called account logic. Logics. I don't know. What do you call this? Account logics is good. Or show account. Account. Perfectly fine. So what object we gonna pass? I'm gonna pass account. Account. So here I will quickly put some statement system.out.println account. Right now in banking client one, I'll try creating an object of accounts account business logic ABL is equal to a new accounts business logic and I create an object. I create an object. I don't want to print it here. I'll get rid of this. I don't want to print it here. I just don't want to print it here. The pension amount, I'll get rid of this. The debiting amount, okay, so let this be added. Rather, what I can do is ABL dot show account. Show account. So this guy, what is it? What is he doing? Is showing the account. So now this time I just want to have another method which is called as debit amount, which account account. So now when I want to debit it, Now, when I want to debit it, there are a lot of rules which is written. There's a lot of rules which is written, which you don't have to. We don't have to even call account debit. Here I can say, here I can say ABL dot debit amount of some account. I don't have to give account. I'm sorry about it. I have to give an account plus I have to have double amount to be debited. So here I give an account and I'll say the account is this, amount to be debited is like 7,000. So imagine something like this. Does it make sense? So what we did, we went on to show account and we went on to debit account with the account type. So what I do is I'll go back here and invoke account dot debit amount of amount to be debited. So we're just debiting the amount. Everywhere, if you see, it is more of a very cohesive approach. So first and foremost, if you're looking at a different perspective, look at this code. Just by looking at this code, very importantly, can this piece of code handle the business logic of current account? Can it handle the business logic of savings bank account? The answer is yes. This guy pretty much can handle everything what is needed for savings bank account, current account. Tomorrow I have RD account, anybody for that matter. This guy can easily handle it without any hassles. So the only thing what your client has to do is every time you want a job, you just have to delegate it to account business logic. This guy will pretty much take care of everything. In similar fashion, if I want to print or if I want to get overdraft or whatever, you don't have to do any job here. You're printing it, don't do that. We just call the other guy. So we just want to get rid of all these things. Here we'll have the first thing is show amount. I'll say ABL dot show account of account. Look at this. It's pretty clean. It's very clean now. The client has no complication at all. Client has no complication at all. So then we will have something like this. Um, show account. I'll say ABL. We may have to have overdraft. Okay, why are we doing all this? Why do we need? Let's do that. Let's do that. I want to know what is the overdraft amount when I do that show account. So in order to do that, here I'll just put a statement if account account. We have this important statement here. Let's do this. I'm sure that we are all aware of a few statements. 10 plus 20 or 20 minus 5 kind of thing. So we call 10 and 20 as operand. The plus is called as operator. So I hope this is making sense. 20 is called as operand, 5 is called as operand, minus is called as operator. In Java also we have few operators which is plus, minus, divide, multiplication and modulus. In addition to all these things, we also have a new guy who is called instance of. This is a new operator. This is a new operator. The instance of operator will take two parameters. The first parameter is called the object of the variable. The second parameter is the class to which it belongs to. The way how we write is something like this. Here is account instance of savings bank. Okay. So here, if account is instance of saving bank. Okay, just before that, I want to show you one more important. Sorry, let me delete this. Just little draw back. Here, I want to give the account. So I'll say show balance. So hope Yeah, this debit amount, okay, let it be. I can say show account, perfectly fine. Here, here in my account, I'll say I want to show the pension. In order to show the pension, what happens is account is something which I get. Account is something which I get. Here, I want to get savings bank account, savings bank account dot get pension. So here, I'll say system dot out dot println pension is. So here, I'll close it. Make sense? So this method is, let's have a look at this. This method, which is called a show account, will pretty much try taking an account. Now, what kind of objects we'll get? Here, we will get savings or current. This method will perfectly work fine if it is a savings bank account, saying that the pension is coming from a method which is called as get function, which is there in the savings bank. So if you just go back to get client and delete this part and invoke it, and then invoke it, it works fine. So it says that sorry, transaction cannot be done, but you see that there is a pension called as 800. But if I introduce the old code with a show balance, this will give you a problem. This will give you a problem. The problem here is called as class cast exception. The reason is something like this. If I have an account which is savings bank account, if I have an account which is called as current bank account, they have some properties which is taken from account. So this is perfectly fine. So if you have a method called as A and B, this has a method called as D and E. And if I have a method which is accepting the parameter of account, which is here, this is some method like our show balance. Here I do something called as ACC dot A. ACC dot A. So what A is, since it's account object, there's a method called as A. This works fine. Likewise, I'll say ACC dot B. Since it's an account object, B does fair job. Perfectly fine. But if I say ACC dot D, this is not visible. If you want to make it visible, what we do is we will typecast this object with savings bank. If you pass an object of savings bank, this will work fine. If you pass an object of savings bank, this will work fine. But if you pass an object of savings bank, but unfortunately in savings bank you have a method called as E, and there is no method called as E here, it refers to D. Since the object currently which I've got is D, this will obviously create a complication. The whole idea here is I want to make sure this piece of code is as reusable as possible. We have to make sure this code is reusable as possible so that we will not have any complications here. And the client has a very clean code. In order to do this, if I execute this on my console, what happened? The estate day 4 current account cannot be casted for savings account for a simple reason. There is one method has a problem. Now, where is this happening? Let's go to account business logic and click on line 9. Here is the problem. So it means your current account for the first time the savings account came, that was having get pension. But if you see current account, these people did not have pension. They have something called as old. In order to maintain the easiness, what I do is I make if account instance of savings account, then only I will execute this part. Only then I'll execute this part. Else, if account is instance of current account, I'll say account dot get overdraft. Get overdraft. I'll put this inside system dot out dot println. So here, overdraft granted is. Hope this should make sense for us. Have an Tomorrow, if you have hundreds of methods, all complications will be kept here, and the client code will be very clean. It will be very simple, in fact. Let us do that here. You don't have to do debit amount, of course. Debit amount, we'll keep it on hold for some time. And look at this, the code is pretty clean. So what people did is they just created an object and they just say show balance. You remember we used to write this statement of showing the pension, showing the overdraft, and all those things. Here it is. This is your old code. So here, look at this. We wanted to get this pension amount. We want to get this pension amount. We want to show this overdraft. You don't have the complication at all here. And moreover, every time we are not using savings plan, current account, and so on. If you have like millions of different types of child classes, every time you have to hold their own instance and you have to repeatedly do it. Rather, you can hold only one variable. In fact, I'll also show you the version 3 now, which will be much effective. So now if I just click on play, oh, great. Here I have the complete history. I just want to mix this with one more example where I want to have banking client 3, very important class. Let's pay a little more attention. Banking client 3, that's another class where we have a main method. This time I want to go a little fancy. I want to have account, accounts, which I just use a plural form, no hard and fast rule. So this guy is equal to new account of something like five elements or five objects. So here we are constructing five elements. So when I say new, in your memory, what's going to happen is there's a variable which is called as accounts. There's a variable which is called as accounts. This will eventually have the array created of five blocks 0, 1, 2, 3, 4. As of now, till now, as of now, it only creates a new memory here. It just points it. It just points it here. What is there here? It is only null. It is only null. Make sense? Null. That is what is happening. So now, what we want to do is we wanted to have accounts of at the zeroth position. I want to have new savings account. Perfectly fine. So who is this person? Let's have one or two. I want to have rate of interest is 405. The customer name is Cami. I want to have some balance of like 7,000. The pension is like 780. That's perfectly fine. So here, I want to have a couple of more accounts. So there are a couple of them happen to be the current account. So here, the account number, I just give like 10, or let's give some series, 201. This is 5.6. The customer name is CB. The balance is like 8,000. The overdraft, they sanction like 30,000. All right, perfectly fine. So there's another current account which you want to make it. I'll just copy the same account here. Let's say 202, and this is they have the same value, and we want to have 30. I want to have 8,500. So here it is 34. So here I have a couple of records with Cami. So let's go ahead and quickly change it. So I want to have Ashwini. So there is a balance of 8,000. This is 666. So I have the next account, which is called a Michael. So now Michael has 7,800. So here you have 555. So that's something which you want to do it. Now there are like hundreds and thousands of accounts. So you have to do like little mapping in the brain, a lot of permutation combination. Thousands of people will hold accounts, and there are hundreds of different types of accounts. So for all the things, if I try having individual um, um, elements or something like variable types, it's so hard to maintain everything. Rather, we want to keep it something like this. So this way, we make the objects getting created at the different position, 1, 2, 3, 4, and so on. Now, I want to iterate, but when I iterate, I want to show all the account details. And I don't know what kind of account details is. But good thing, what has happened so far, if you see this business logic, this guy show account, if you just see the highlighted part, show account, this guy can pretty much handle anything. If you savings account, he can handle. If you have checking account, he can handle. Tomorrow you will come out with a recurring deposit amount, still they can handle. So now what I do is, quickly I just run a for loop for int I is equal to 0, I less than accounts dot length, because that will give you the length. So the length here is 5, I plus plus. I will say, hey, I want to have accounts, account business logic ABL is equal to new account business logic. Here I'll say ABL dot show, which is accounts of I. Look at this. The client has no business to know what methods are there, how it is working, nothing. You just have to say, hey, look at this boss, give me the arrays, the list of arrays what you want with the customer information or whatever. Then just iterate, and we will do rest of it. And the person, when you come for business logic, here the entire story is executed. So that's like super cool. All your complication is hidden between the user and the developer. Oh, have a look at this. So you have Cami, Ashwini, Sibi, Michael. They have like different types of account. So what is their account? They have like overdraft account. There is a current account. They have overdraft account, which is current account. The rest all are like savings bank account. So they're like pretty interesting thing where we keep the objects pretty clear. This understanding is where we introduce something called as polymorphism in Java, where the same object here, same object called as behaving differently at different point in time is called as polymorphism. So here I'm called as a instructor. After some time, I'm called as somebody's father. I'm called as somebody's husband. I'm called as somebody's friend. I'm somebody's uh, son, whatever. So, same object behaving differently at different point in time is where the concept of um, polymorphism will come. And it reduces the code drastically over a course of time. There's a lot of work which we're going to give it for compiler, or I'm sorry, the runtime executor for doing it. So that's where we have the polymorphism. We make use of inheritance. These two concepts go hand in hand. And encapsulation, of course, you may have to know the access specifiers, what is private, public, protected, default.
Thank you for watching. See you in the next video.